Hi everyone. Today we're going to learn about how to use Pascal's triangle to expand the powers of a binomial. So Pascal's triangle, if you've never seen it before, is a triangular array of numbers, and it was named after the mathematician Blaise Pascal, who explored many of its properties. It has wide-ranging applications from probability theory. If you take data management, you'll see it there, to expanding powers of binomials, which is what we're going to focus on today. The expanding powers of binomials often helps in calculus and further courses with proofs, but we're just going to use it to expand generic binomials that you guys know. So if you look at Pascal's triangle, it starts with a 1, and then that's called row 0. The second row is 1 and a 1. The second row is 1, 2, 1. So each row starts with a 1 and ends with a 1. How do you get the numbers in the middle? So if you see 1 plus 1 gives you this 2 in the middle. And then here we start with a 1. 1 plus 2 gives you this 3. 2 plus 1 gives you that 3. And then you end with a 1. Start with a 1. 1 plus 3 gives you the 4. 3 plus 3 gives you the 6. 3 plus 1 gives you the 4, and then you end with a 1. For row 5, starts with a 1. 1 plus 4 gives you 5. 4 plus 6 gives you the 10. 6 plus 4 gives you the second 10. 4 plus 1 gives you 5 again, and it ends with a 1. For row 6, starts with a 1. 1 plus 5 gives you 6. 5 plus 10 is 15. 10 and 10 is 20. 10 and 5 is 15. 5 and 1 is 6, and it ends in a 1. So knowing the pattern without looking at it, I can just say, okay, row 0 is 1, then 1, 1. 1, 1 and 1 is 2, ends with a 1. Row 3 starts with a 1, 1 and 2 is 3, 2 and 1 is 3 again, and ends with a 1. Row 4 starts with a 1, 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and it ends with a 1. And again, row 0, row 1, row 2, row 3, row 4. So you can see that row 0 is just the top row. Row 1, the second number in is a 1. Row 2, the second number in is a 2. Row 3, the second number in is a 3. Row 4, the second number in is a 4. So we should expect row 5, the second number in will be a 5. So it starts with a 1. 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and it ends in a 1. Row 5, the second number in is a 5. Row 6 is going to start with a 1, 1 and 5 is 6, 5 and 10 is 15, 10 and 10 is 20, 10 and 5 is 15, 5 and 1 is 6, and it's going to end with a 1. So it's kind of like a recursive table. Like once you know the pattern, you could extend it as many rows as you wanted to, but one row at a time. So you would have to, if you wanted row 8, you would have to first do row 7. So row 7, 1 and 6 is 7, 6 and 15 is 21, 15 and 20 is 35, 20 and 15 is 35. 15 and 6 is 21, 6 and 1 is 7, ends with a 1. So if I wanted row 8, 1 and 7 is 8, 21 and 7 is 28, 21 and 35 is 56, 35 and 35 is 70, 35 and 21 is 56, 21 and 7 is 28, 7 and 1 is 8, and it ends in a 1. Another couple things about it is that row 0 has 1 term, row 1 has 2 terms in it, row 2 has 3 terms in it, row 3 has 4 terms in it, row 4 has 5 terms in it. Okay, so there's always one more than the row number of terms in Pascal's triangle in that specific row. Often the champagne glass is used to see maybe where the numbers come from. So you're pouring one glass of champagne into the top of the champagne fountain. So here's my first one, is kind of row 0 here, where there's no cups at all. Okay, so I'm just pouring in. Now, to get into the next row of cups, there's only one way. I can only come out of this champagne. To get into this cup here, there's only one route for me to come in. And to get into this champagne cup here, there's only one route to get into it. So here's my row 1. And then to get into the second down layer of cups, there's only one way to get into the top row. Now this is the second row here. Now we're on the third row of cups. So to get into this cup here, there's again only one way to get into it, and that would be it comes from this cup, then comes from this cup, then comes from this cup. So there's only one way to get into this cup here. Okay, so maybe I should have put, there's only one way to get into this cup here, one way to get into this cup, and one way to get into this cup. That probably makes more sense there. So there's our row 0 and our row 1. So here's our row 2. So to get into this cup here though, I could have come into this cup and down, or I could have come into this cup and down. So there's two ways to get into this cup. And to get into this cup, I would have had to go over this edge and this edge. So there's only one way to get into that cup. And then row 3 of cups here has 4 cups in it. Remember, there's always one more. So again, I would have had to come down here, here, and here. There's only one way to get into that cup. To get into this cup, I could have done this and this and this, or I could have done this and this and this. If there was one way to get into this cup and 2 ways to get into this cup, and altogether there would be 3 ways to get into that cup. Same with this one. There was it can either come from this cup or this cup. 2 ways to get into this one, 1 way to get into that one, so 3 ways to get in this one. And here, to get into this last cup, I would have had to go down, down, down. Only 1 way to do that. And you can keep adding rows. All right, so now we're going to see, how does this array of numbers, Pascal's triangle, relate to expanding binomials? So again, a binomial is 2 terms, and a power of a binomial is to a power. So anything to the power of 0 is 1, so that's an exponent rule. So x to the power of 0 is equal to 1. Anything to the power of 0, so I could have 13 to the power of 0 equals 1. 5x all to the power of 0 equals 1. And in this case, x plus y all to the power of 0 equals 1. Anything to the power of 0 is equal to 1. And anything to the power of 1 is equal to itself. So this is x plus y. X plus y squared. So here we would have to do FOIL. X plus y times x plus y. Expand it out here. And we're going to get x squared plus x times y is xy, plus y times x is xy again, plus y squared. And then these are like terms, so it's x squared plus 2xy plus y squared. X plus y cubed, so I can think of x plus y cubed as x plus y times x plus y squared based on exponent rules. So if I kept the base x plus y and added the exponents, I would get back to x plus y cubed. And we just figured out in C that x plus y squared was equal to this. And then I can use the FOIL idea again, but it's a lot. I've got 6 multiplications to do. 3 here, and then 3 more to do here. So that's going to give me x times x squared is x cubed, plus x times 2xy is 2x squared y. X times y squared is xy squared. Now I'm going to multiply the y. Y times x squared is yx squared, or I can write it as x squared y alphabetically. Y times 2xy is 2xy squared, and y times y squared is y cubed. And then if I simplify any like endings, I've got a 2x squared y and a 1x squared y that gives me 3x squared y. And then I've got an xy squared and a 2xy squared that I can add together to get 3xy squared. And then I have the y cubed. So if I exaggerate the coefficients, x plus y to the power of 0 is 1. X plus y to the power of 1 is 1x plus 1y. So if I'm looking at Pascal's triangle, 1, 1, 1, and I'm just looking at the coefficients here. The coefficients of x plus y all squared are 1, 2, 1. And the coefficients of x plus y, put them up here. So the coefficient, so for x plus y to the 0, it's 1. X plus y to the 1, the coefficients are 1 and 1. The coefficients of x plus y all squared are 1, 2, and 1. Okay. And the coefficients of x plus y all cubed down here are 1, 3, 3, and 1. 1, 3, 3, and 1. So if I were to guess what the coefficients of, so I'm going to put a little line here. If I were to guess what the coefficients of x plus y all to the 4th would be, this seems to be following Pascal's triangle. So when the exponent was 0, I was at row 0. When the exponent was a 1, I was at row 1. When the exponent was a 2, I was at row 2. When the exponent was a 3, I was at row 3. So I'm assuming I'm going to be at row 4 when the exponent's a 4, which is going to be 1. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4, ending in a 1. So if I use that prediction, I would expect my coefficients to be 1, 4, 6, 4, 1. But then also look at this pattern here. So when it's to the power of 3, I started with 1x cubed. When it was to the power of 2, I started with 1x squared. So when it's to the power of 4, I'm going to start with 1x to the 4th. And then what's in between the terms? We're adding them each time because we're always, it's x plus y. So plus. So here we had a 3 because we were in row 3. That was our coefficient. But the exponent on the x went from 3 to 2. So we're going to expect here the exponent on the x to go from 4 to 3. And here there was no y. All of a sudden there's a y to the 1. A y to the 1. Again, you don't need to show that 1. And then plus. So then what happens next? I have my next number from Pascal's triangle. And the exponent on x is now a 1. So it reduced by 1 again. So x to the 4th, x cubed, x squared. And then the exponent on the y, here I could think of this as y to the 0, which is 1, so it's not there. Increases by 1, increases by 1. So increases by 1 plus. Then what's going to happen next is I'm going to have 4, And then my exponent on x is going to decrease by 1 again to make it x to the 1. And my exponent on y is going to increase by 1 again. Plus, finally I've got end with my 1. My exponent on x will decrease by 1, which makes it x to the 0. But x to the 0 is 1, so you don't see the x there. And you end with 1y to the 4th. So, if you were to expand that out by doing x plus y, like using FOIL, so doing x plus y to the 4th, and instead expanding out x plus y times x plus y cubed and doing all that FOIL, this is what you would end up with. So it's like a pattern that follows from Pascal's triangle, which saves you a lot of time in doing a lot of FOILing to get there. So that was our e, x plus y to the 4th. So we determined that it was going to be 1, the first. So if we look at, I can get this over here. So we're looking at the 4th row of Pascal's triangle. So it's going to be, oops, can't see it in here. Move it over here. Up here, and I'll move this down so we can see them both at the same time. So we're looking at the 4th row. So x plus y to the 4th is going to start off with a 1 x to the 4th plus the second number in on row 4, 4, reduce the exponent on x by 1, increase the exponent on y by 1. So it went from y to the 0, which didn't even show up, to y to the 1, plus 6x squared y squared. So the exponent on x reduces by 1, the exponent on y increases by 1, plus 4x to the 1 y cubed plus 1, and then it would be x to the 0, which is 1. You don't need to show y to the 4th. And then you could get rid of the 1 here and just write it as x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. And if it's the exponent of 4, there should be 5 terms because there's 5 numbers in the 5th row, or sorry, in the 4th row of Pascal's triangle. 1, 2, 3, 4, 5. All right, so the expansion of x plus y to the power of n. So it starts off with the first C0, which can be thought of as the first number in the nth row of Pascal's triangle, times x to the power of n times y to the power of 0. And again, remembering y to the power of 0 is a 1, so that's why the y doesn't show up there. Plus the second number in the nth row of Pascal's triangle, x, and the power will reduce by 1, y to the 1, plus the third number in that row of Pascal's triangle, exponent on x reduces by 1, exponent on y increases by 1, and on, and so on and so on. Where C0, C1, C2, C3 up to Cn are the coefficients in the nth row of Pascal's triangle. So we're going to try some of these. Use Pascal's triangle to simplify each of the following. So x plus y to the 5th. So I'm going to write over here so we can refer to it. So here's row 5 of Pascal's triangle. Okay, so I just made it, knowing that it starts off with 1, 1, 1, row 0, row 1, and then you add to get successive terms and in the different rows. So x plus y to the 5th then should start off with a 1, which I don't really need to show, x to the power of 5, y to the power of 0. And again, I don't need to show y to the power of 0 because that ends up being 1. Plus, second number in row 5, 5, x to the 4th, y to the 1. Plus 10, x to the 3rd, y squared. plus another 10 x squared. So again, the exponent on x is reducing by 1 each time, and the exponent on y is increasing by 1 each time. Plus 5x to the 1, y to the 4th, plus 1, which I don't need to show, x to the 0, which is also 1, which I don't need to show, y to the 5th. So without doing any FOIL, just using Pascal's triangle, we've gotten x plus y to the 5th all expanded out and all of the like terms collected without doing FOIL a bunch of times. And collecting all those terms, it would take a really long time. So now we changed the y to a 2. So how does that change things? So this 4 means I need to refer to the 4th row of Pascal's triangle, which we can see here. So it's going to start off with the 1, which we don't need to show, x to the 4th, 2 to the 0, and 2 to the 0 is 1, which I don't need to show, plus second number in row 4 is a 4, x cubed, and then it would be a y, but it's not, it's a positive 2 times positive 2 to the 1, okay? And I don't really need to show the to the 1. Plus, the next number in the 4th row of Pascal's triangle is a 6. Then the exponent on x is going to be reduced by 1, and the exponent on 2 is going to be increased by 1. Plus, the next number in Pascal's triangle is a 4, x to the 1, 2 to the 3rd. Plus, the last number in that row is a 1, which I don't need to show. X to the 0 is 1, I don't need to show that. 2 to the 4th. So now I've got to simplify it a bit more because I can combine some things. So the x to the 4th is going to stay, but I can multiply because they're both numbers, 4 and 2. So this is really 3 things multiplying together. 4 times x cubed times 2. But I can multiply the 4 and 2 together to get 8. So x to the 4th plus 8x cubed. Plus, so if I look at this one again, I've got a 6 times an x squared times 2 squared. But I know off my calculator in my brain that 2 squared is really 4. So I can multiply the 6 by the 4 and get 24x squared. Plus, so now I'm looking at this term, I've got a 4, an x, and a 2 to the power of 3. And 2 to the power of 3, I can either use my calculator or my brain, I know is the number 8. So I can multiply 8 by 4 and get 32x to the 1. And then plus 2 to the 4th, I can figure that out on my calculator in my head is 16. So notice, here's my numbers from Pascal's triangle for the 4th row. 1, 4, 6, 4, 1, okay, out in the front. But I don't see them in my final answer because I've multiplied by the different powers of 2 that appeared, because instead of a y or a variable, I had a number in that position that I could evaluate. So if I was to expand that out using FOIL, so multiplying it all through and collecting like terms, I would end up with x to the 4th plus 8x cubed plus 24x squared plus 32x's plus 16 1s, and that would be true. But this is a lot quicker way of doing it. Okay, 5x plus 2y cubed. So we're going to need the 3rd row of Pascal's triangle. So row 0 is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So this is row 3 here. So I know I'm going to start off with a 1, which I don't need to show, times the first part of my binomial. In this case, that's a 5x and it's all going to be cubed. And then I'd have 2y to the power of 0, which is 1. Okay, I might write that in this time just so we realize that anything to the power of 0 is 1. Okay, so that's the first term, and there's my 1 out front, and I'll write those in as well so we can see that they follow Pascal's triangle. Plus, so then I've got my 3 from Pascal's triangle. And then it's going to be 5x squared, so the power reduces by 1, times 2y to the 1. Plus, so I've done the first two numbers in Pascal's triangle, row 3, 3 again, 5x to the 1, 2y to the 2, plus 1, so my last number in row 3, and I have to erase a bit here to fit it in. It's going to be 5x to the 0, which is 1, times 2y cubed. So what happens when I try to simplify this? So we need to know our exponent laws pretty well for this. So 1 times anything is 1. 5x all cubed. 5x all cubed. So there's a couple ways people think of this. One is to think of it as 5x times 5x times 5x, which is 125x cubed. Okay, so that's kind of the grade 9 way we thought about it. And then in grade 10, we thought about it as 5 cubed x cubed, and 5 cubes a number we can figure out on our calculator is 125. Okay, so this is probably the way I would like you to think about it. So 5x cubed is 125x cubed, and anything to the 0 is 1 times 1. So 125x cubed times 1 is still 125x cubed. Plus, so now we've got this term here. So let's think about this term here. So there's a 3, that's our Pascal number, times 5x all squared times 2y to the 1. So if we're thinking about this, so that's 3, 5x all squared is 5x times 5x, so that's 25x squared, and then times 2y. Okay, and we can see that that's going to end up being 3 times 25 times 2, which is 150, x squared y. And we can do that work on the side, and we can see that that's what you do. But if you want to use your calculator, you're going to realize, okay, that number out front, that 150, is made by, on my calculator, doing 3 multiplied by 5 to the power of 2 multiplied by 2 to the power of 1, which is just 2, and that gives me my 150. And then my variables, x squared, y to the 1, y. Plus, so if I follow that idea here, to get the numerical part, it's going to be the 3 from Pascal's triangle, 3 times 5 to the 1, which I know is 5, times 2 to the power of 2, which is 60. So the number is going to be 60, x to the 1, which is x, y squared. Plus, so 1, 5x to the 0 is also 1, because anything to the 0 is 1. So 1 times 1 times 2y cubed. So 2y all cubed, the number is going to be 2 to the 3rd, which is 8y cubed. So x minus 3 to the 5th. We want to go down to the 5th row, so I'm going to use, this was the 3rd row, 1 and 3 is 4, 3 and 3 is 6, 4, 1, and then 1, 5, 10, 10, 5, 1. So So those are my Pascal numbers. So I'm going to start off with my 1, and then it's going to be x to the 5th, careful with the negative, -3 to the 0, plus the next number in Pascal's triangle is a 5, x to the 4th, -3 to the 1. Next number in a Pascal's triangle is a 10, so plus 10 x to the 3rd, -3 squared. Plus, next number in is also a 10, x squared, -3 cubed, plus 5 x, -3 to the 4th. Oops, this 5 should have been green. Plus 1 x to the 0, -3 to the 5th. So -3 to the 0 is 1, so 1 times 1 times x to the 5th is x to the 5th. Now before I'm going to write a sign down here, I see I've got plus 5 times -3 to the 1 times x to the 4th. So the 5 and the -3 are going to multiply together to give me -15 as the coefficient times x to the 4th as the variable. Here, I see I'm going to get my coefficient by multiplying positive 10 by -3 squared. And when you square a negative number, you get a positive number. So that's going to be 10 times 9, or 90 x cubed. So I've done that term, that term, that term. 3 terms so far. And because it's to the power of 5, there should be 6 numbers in that row of Pascal's triangle, so there should be 6 terms altogether. And I've got the first 3. So now to get the coefficient for the next term, it's going to be 10 multiplied by -3 cubed. So when you use your calculator, maybe use brackets. -3 to the power of 3 times 10 gives you -270 x squared. Here I've got -3, so I'm going to use brackets again. -3 to the power of 4 is positive 81 times 5 is positive 405 x. And then the last one, 1 x to the 0 is also 1 times -3 to the 5th. -3 to the power of 5 is -243. So x minus 3 to the 5th expands out to give you, instead of doing FOIL 4 times, we can do Pascal's triangle. It's going to give me x to the 5th minus 15x to the 4th plus 90x cubes minus 270x squared plus 405x minus 243. You can see the powers of x go down, in this case by 1 each time. And because we have a negative, we alternate signs. So we start with a positive, then a negative, positive, negative, positive, negative. And that has to do with when you're putting a negative to an odd power, you get a negative, and when it's to an even power, you get a positive. Okay, 2q minus 3 to the 7th. So the 7th row of Pascal's triangle, I'm just going to write it up here. So I'm going to take it from this one that I made up here myself. So it's 1, 7, 21, 35, 35, 21, 7, 1. Okay, so those are my Pascal numbers. So this one I've left a lot of space for. So I'm going to do my Pascal numbers in pink because my green's running out here. So I'm going to start off with my 1, followed by whatever's first. So 2q in this case to the 7th, followed by whatever's second, which is -3 to the 0. My second Pascal number is a 7. 2q to the 6th, negative 3 to the 1. Plus, my third Pascal number is a 21. 2q to the 5th, negative 3 squared. So the exponent on 2q is decreasing each time, and the exponent on negative 3 is increasing by 1 each time. So done, done, done. So now I'm on to 35. 2q to the 4th, negative 3 to the 3rd. Another 35. 2q to the 3rd, negative 3 to the 4th, plus a 21. 2q to the 2nd, negative 3 to the 5th, plus a 7. 2q to the 1, negative 3 to the 6th, plus a 1. 2q to the 0, negative 3 to the 7th. Okay, so, and if you look at this, that's 1, 2, 3, 4, 5, 6, 7, 8 terms that now need to be simplified. So if we look at our first term, so we're going to use that idea that we had on our calculator here. So 1 times anything keeps it the same, and negative 3 to the 0 is also 1. So we're focusing on this 2q to the 7th. And we know we can think of 2q to the 7th as 2 to the 7th q to the 7th. So 2 to the 7th is going to be the coefficient. So 2 to the power of 7 is 128. So 128 q to the 7th is the first term. To get the second term, the coefficient is going to be made by doing the 7 times the 2 to the 6th times negative 3. So 7 times 2 to the power of 6 times negative 3 is negative 1,344. So I shouldn't have put a sign down yet. So negative 1,344, and then q to the power of 6. Third term, the coefficient part is going to be done by doing 21 times 2 to the 5th times, I'm going to use brackets, negative 3 squared. Positive 6,048 q to the 5th. My first 3 terms done. Next coefficient I'm going to get is going to be got by doing 35 times 2 to the 4th times negative 3 in brackets to the 3rd. So that's negative 15,120 q to the 4th. Notice the q is going down by 1 each time in this case. My next one, so plus, my coefficient is going to be got by doing 35 times 2 to the power of 3 times negative 3 in brackets to the power of 4, which is positive 22,680 q cubed. My next term, so my coefficient is going to be got by doing 21 times 2 squared times, in bracket, negative 3 to the 5th, which gives me negative 20,412. So I can't fit that there, so minus 20,412 q to the power of 2. Second last term, so my coefficient is going to be 7 times 2 to the 1, which is just 2, times negative 3 in brackets to the power of 6, which is 10,206, q to the 1, and then 2q to the 0 is 1, so 1 times negative 3 to the 7th, negative 3 to the power of 7 is negative 2,187. And if we're to the power of 7, there should be 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. And that would be a lot of FOIL to do. So even though this does take time and you have to be very logical and methodical about it, it takes a lot less time than doing FOIL 6 times. Okay, F. So we need the 4th row of Pascal's triangle, which I can get from where I drew it out. So here's my 4th row, 1, 4, 6, 4, 1. So I'll write that above here. So we're going to start off then with our 1 from Pascal's, the 4th row of Pascal's triangle. This time 2 comes first, so 2 to the 4th, negative 1 over x to the 0. So that's our second part of the bracket, is this negative 1 over x. Plus 4, second number in Pascal's triangle, 2 to the 3rd, negative 1 over x to the 1. Plus, third number in Pascal's triangle is our 6. 2 squared, negative 1 over x squared, plus 4 times 2 to the 1 times negative 1 over x cubed, plus last number in the 4th row is a 1 times 2 to the 0 times negative 1 over x to the 4th. So now we want to simplify these. So each little grouping is 3 things multiplying together. We've got a 1, and anything to the 0 is 1. So we just end up with our first term being 2 to the 4th, which is 16. Our second term, since we've got a fraction here, so one rule that I want you to remember is when you have a fraction to an exponent, so we just went over this rule, so if I have x over y to the 5th, it's the same as having x to the 5th over y to the 5th. Okay, so remember that rule, that's an important one for simplifying this out. And then also remember that if we just have a number like 2, we don't see its denominator, but it's a 1. Okay, so both of those things are going to be helpful when we simplify this. So I can think of 4 as being 4 over 1, and 2 cubed as being 2 cubed over 1, and then negative 1 over x to the 1 as negative 1 to the 1 over x to the 1. So in the numerator, I'm going to have 4 times 2 cubed times negative 1 to the 1, which is just negative 1. So my numerator is going to end up being negative 32, so minus 32. My denominator is going to be 1 times x to the 1, which is just x. So we've done that one. So same idea here. My numerator is going to be 6 times 2 squared times negative 1 squared, which is positive 24. And my denominator is going to be 1 times 1 times x squared, because this 2 on the outside of the brackets applies to the numerator and the denominator, which is just going to give me x squared. So here I can do my 4 times 2 to the 1, which is just 2, times negative 1 to the power of 3. That gives me negative 8. And for my denominator, it's 1 times x cubed, which is x cubed. And then 2 to the 0 is 1, so I've got 1 times 1. So really all I've got to evaluate is the negative 1 over x to the 4th. So negative 1 to the 4th is positive 1 over x to the 4th. And that is the expansion of 2 minus 1 over x to the 4th. And our last one and trickiest one, so I've got to the power of 6, so I need row 6. So if we go back to Pascal's triangle, row 6 is 1, 6, 15, 20, 15, 6, 1. Okay, so we're starting off with our 1. X squared to the 6th, 3 over x to the 0, plus 6, x squared to the 5th, 3 over x to the 1, plus 15, x squared to the 4th, 3 over x to the 2, plus 20, x squared to the 3rd, 3 over x to the 3rd, plus 15, x squared squared, 3 over x to the 4th, plus 6, x squared to the 1, 3 over x to the 5th, plus 1, x squared to the 0, 3 over x to the 6th. Okay, so remembering back again another exponent rule. So x squared cubed is the power to an exponent rule, x squared cubed. You keep the base x and multiply the exponent. So x squared cubed is x to the power of 6. So, and then anything to the 0 is 1. So I've got 1 times x squared to the 6 is going to be x to the 12th. Because you keep the base and multiply the exponents 2 times 6. All right, so if we look at this second one here, get a piece of paper to write this out on, the second term here, 6x squared to the 5th, 3 over x to the 1. So if we just look at this, how are we going to get our number part or our coefficient? It's going to be 6 times 3 to the 1. So that's going to give me 18. And then x squared to the 5th is x to the 10th. But in the denominator, I'm going to have 1 times x to the 1, which is x. So in the second term here, I've got 18x to the 10th over x. And I'm going to be able to simplify that a little bit more. For my next term, The number part's going to be 15 times 3 squared. 15 times 3 squared is going to be my coefficient, so 135. But then also times x to the 8th. But the denominator, 1 times x squared, is x squared. Next term, so my coefficient is going to be 20 times 3 cubed. 20 times 3 to the power of 3, which is 540. But x squared cubed is x to the 6th over 1 times x cubed, which is x cubed, plus 15 times 3 to the 4th is going to be my coefficient. 15 times 3 to the power of 4. 1,215. Also in the numerator is going to be x to the 4th. But in the denominator, I also have 1 times x to the 4th, so x to the 4th. Plus, so now I'm looking at this term. My numerator is going to be, the coefficient is 6 times 3 to the 5th. 1,458 x squared to the 1 is x squared, over 1 times x to the 5th, plus, so 1 x squared to the 0 is also 1 times 3 to the 6th, so 3 to the power of 6, which is 729, over x to the power of 6. So then how can we reduce this using exponent rules? So we've got x to the 12th. Here we've got, this is like 18 x to the 10 minus 1. So we're dividing powers with the same base. So we keep the base x and subtract the exponents. So 10 minus 1 is 9. Plus 135 x to the 8 minus 2, 6. Dividing powers with the same base, plus 540 x to the 6 minus 3, which is 3, plus 1215 x to the 4 minus 4, which is 0, and anything to the 0 is 1, so we don't, or you can think of them as just dividing out, plus 1458 x to the 2 minus 5, so now we've got a negative exponent. We'll deal with that on the very last line. And then same thing here, or actually this one we can just leave as 729 over x to the 6th. And then for our last line, we don't want to have a negative exponent in our answer, so the only thing that has a negative exponent is that one term. So I can write 1458 x to the negative 3 as 1458 over x to the 3rd. And even though the exponent doesn't go down by 1, it goes down in a predictable way, and that's because we have an x squared here and an x in the denominator here, but we start with an x to the 12th, then an x to the 9, so the exponent on the x goes down by 3. Goes down by 3 again to x to the 6, goes down by 3 again to x to the 3, goes down by 3 again to x to the 0, and then x to the 3 in the denominator is really x to the negative 3, and x to the 6 in the denominator is really x to the negative 6. And that would be like the hardest expanding binomial Pascal's triangle question that you could get. All right, so that is how you use Pascal's triangle to help you expand powers of binomials.